Have you ever wondered what exactly is the air that we breathe? A very simple but at the same time more complex question than it might seem at first. We have always been told right from when we were children that it's a homogeneous mixture of gases, mainly nitrogen, oxygen and other substances, such as carbon dioxide or methane. But is that the air that we actually breathe? Did you know that the World Health Organization attributes 1 in 20 deaths to atmospheric pollution? And the fact that the aeronautical industry is responsible for 2% of global emissions of carbon dioxide and for 12% of total emissions from transportation sources. So, what can the aviation sector do about this? First, we must characterize the atmospheric emissions in order to determine their impact on the environment and on human health, and in this way be able to offer possible solutions. To do this, it will be necessary to invest many hours of testing new measuring technologies and access to the sources of contamination. However, sampling of particle emissions in airports are expensive and require favorable conditions to obtain satisfactory results, facing multiple challenges. First, access to the emission sources, since approaching an aircraft exhaust plume in an airport is not easy at all. Favorable weather condition because it's only permitted to stay at a minimum distance of 150 meters in the perpendicular direction of the exhaust plume, and you have to be lucky enough for the wind to be blowing in the right direction. Good coordination with the control tower, as the register must be synchronized with aircraft maneuver in order to establish correlation with the measurement. Capacity to assure that the registered emission is only coming from the aircraft and not from the airport vehicles and other ground sources in the surroundings. And finally, there is a huge diversity of aircrafts with different engines, and it's necessary to wait for a similar one operating in the same conditions to be able to repeat the test which check the accuracy of the results. In our institute, we have been generating knowledge about the aviation sector for many years, and we have achieved an alternative way of investigating the emissions produced by the enormous engines of commercial aviation in order to find out the kind of air we breathe. We have supplied our Turbojet test cell with the means and qualified technology. Our methodology is based on 2 well-differentiated sampling points, one in the exit plane of the engine used by engine manufacturers for regulatory purpose, and the other at a distance of 40 meters, which we consider is the most representative for the analysis of environmental impact. The comparison between data records of these 2 sampling points will be decisive for the creation of model of physico-chemical evolution of non-volatile particles and for the characterization and transformation of the volatile compounds. Thereby, with this scientific technological infrastructure, we solve many of the sampling difficulties previously seen. We have a bounded area with known environmental conditions where we assure that the entire sample collected comes from the engine exhaust plume. We have access to many long-term tests and types of engines, which involves a huge variety of aircraft to include in a data bank. And we have a perfect synchronization between the characterization records of the emissions and the engine test operation data, such as engine power level, fuel consumption, or air-fuel ratio. In addition, our design of the sampling line and the measuring equipment allow us to determine the particle concentration in number and mass in relation to the different landing takeoff cycle phases, study the particle distribution relative to their diameter sizes, analyze the chemical composition, organic and inorganic, in relation to the distribution, and study the morphology of the particles. So we are already prepared to give some answers to our question. This figure shows the numerical particle concentration from engine emissions measured with an electrical low-pressure impactor at the 40-meter sampling point. We found that the smallest fraction corresponding with the first 2 stages, with a cut diameter size between 6 and 27 nanometers, contributes to 90% of the total concentration. Moreover, we have verified that the aviation sector is characterized for modes of particle size distribution that are different from those in the industrial sector and even from those of the automotive sector. Aerosols from the aviation sector have one mode of nucleus between 5 and 20 nanometers, and the other one of aggregates around 70 and 100 nanometers. Therefore, the particles generated in the combustion have a submicrometric size, which is pretty worrying because the smaller the particle size is, the greater penetration it will have in the respiratory system, reaching in this case the alveolar region. We have also taken dozens of samples in the stack and analyzed the composition of pus from the gaseous emissions, and we have found that there is an enrichment of the air with typical compounds from the combustion, particularly in volatile and semi-volatile compounds, although the carcinogenic risk doesn't seem to exceed the threshold of unacceptability from human health. And what is the future? Obviously, this kind of technological platform we have developed at INTA will be useful for continuing this type of investigation, so the new engines and biojets that are currently being improved, many of them as a product of research programs funded by the European Union, should meet the A Careflight Path 2050 goals. This means that the reduction of emissions and pollutant characterization are two of the main issues concerning the aviation sector. Of course, we will be there to keep on researching in order to contribute to develop a suitable environmental model, providing new data and knowledge to support the industry programs and the regulatory agencies' requirements. On this point, we open our facilities to all groups and young researchers who would like to participate in this line of work in assessing new technology and their impact on the environment. We believe that in years to come, we will be more knowledgeable about that very simple but very profound question: what exactly do we breathe, as well as the contribution of science in helping in the reduction of greenhouse gases and nanometric particle emissions. It's encouraging to know that the future of the aviation sector is in touch with respecting the environment. Our air, our aim.